have the periodic table. Can you guys spot where gold is?
Yes, I can. 79 AU.
Okay. I found it. Very good. So now tell me.
Ma'am, AU.
AU, yes.
Oh, ma'am, sorry, ma'am. Sorry, ma'am. A bit late.
That's okay. So AU 79. All right, good. So now can you tell me, in the periodic table, it says that on the left hand side I have metals, on the right hand side I have non-metals, and somewhere in between I have heavy metals. Do you see that?
Yeah.
What are heavy metals?
I'll tell you. So why is it that the ones on the left hand side, those are called metals, and the ones in the middle are called heavy metals? Why do you think that that is the case?
So
They're denser, exactly.
Because of their properties.
Yes, because of their properties. So yes, they are heavier, which is why they're called heavy metals. For example, if you look at this list, you will see, let's see, where you'll see iron, you'll see copper, zinc. All of these are metals that are actually heavy. If you take the same amount of, sodium, and you take the same amount of iron, not in terms of weight, but in terms of, if I fill it up in a box, then iron, for the same size of the box, the one with iron will weigh a lot more than the one with sodium. Why? Because iron is a more denser, heavier metal, which is why in the periodic table, if you see the mid portion of it, you will see that that section is called heavy metals. On the left hand side, what you call those as metals or light metals, whatever. Okay. So now, based on general characteristics, the periodic table has been, created, and so there is metals and then there's non-metals. So of all the elements that have been found in nature, 118, 80% of those are metals and the rest are non-metals, okay, and metalloids. Now, what are metalloids? Do you guys know what metalloids are? Okay, one at a time. Kavya, one at a time. Kavya, go ahead.
It's a wild guess. It's like an alloy of or a mix of non-metals and metals.
Yes.
Wait,
Wait, Arjun, hold on. So, Kavya, it's not an alloy. So don't use the word alloy, because alloy is only used for metals. So when you say yes, it is like it has both properties of metals and non-metals. Okay. Who else? I think Veda, you wanted to say something?
Yes, ma'am, I have the same definition.
Okay, good.
Just saying, Miss
Arjun, hold on. Yes, Veda?
Which has the same, metalloids have the same, both properties of metals and non-metals.
Okay, very good. Yes, Arjun, go ahead.
Just saying all the answers are below the periodic table, 1, 2, 3, and 4, and 5, just saying.
Yeah, I know, that's fine, no worry. I just want like the class to interact as well, so that I know not everybody's sleeping. So, all right. So yeah, can you guys look at the periodic table and tell me what do you think are the examples of metalloids? Phosphorus, sulfur,
boron and silicon.
Boron and silicon, okay. So how do you spot which ones of these are metalloids?
I actually know, because our school teacher gave us the notes in this.
Okay, so the way to figure it out is this. So do you see a pattern here? You can even see it in the periodic table actually.
Yeah, I can see that pattern.
Yeah, do you see that diagonal?
Yeah.
Okay. So
the boron, silicon, what is this element?
GE?
Element.
This is boron, silicon, germanium. I think this is arsenic, or yeah, arsenic. This is antimony, I think. This is tellurium,
Polonium.
polonium, bismuth.
Oh.
Okay.
Yeah.
So these metals which are along the diagonal that separates metals and non-metals are called metalloids. Okay. All right. So okay, now can you guys tell me what periods and groups are? Do you know that? Okay, what is meant by group number?
They're like in a particular line. For example, here it's beryllium, magnesium, calcium, and all that in one line. That one line will be. And the
Okay, so you're talking about vertical line.
Ma'am, there are categories.
Yes, they're categories. So yeah, like Kavya said, vertical lines, right? So those vertical lines, all elements falling under one particular vertical line. Yes, Akriti?
No, ma'am, I don't want to say anything.
Okay, so all the elements that are falling in one particular vertical line, those elements are called, so those elements are said to be belonging to a particular group. So now if you look at the periodic table, how many groups are there? Can you count and tell me? What is it?
8th one.
Oh, you're counting it like that. No, just count the number of vertical, elements that you see. So there are 18, correct? Okay, so there are 18 groups. And how many periods are there? Periods are horizontal ones, okay? Just like how you have vertical. Yes, very good. So the periodic table has 7 periods and 18 groups, okay? So in the title of this slide, it says long form of periodic table. So there is also a short form of periodic table. What you see over here is the long form of periodic table, meaning that all of these elements, all of the 118 elements are present in the long form of periodic table. There is another periodic table, which is nothing but, it's the same thing, but it is written in a shorter form. And that is called the short form of the periodic table. You'll find that usually in a lot of places where the lanthanides are placed on the bottom separately. So yeah, that is the reason why that is called as the short form, because it looks shorter, smaller, and this is called the long form of the periodic table. So metals are towards the left and the center, we saw that. Non-metals are to the extreme right.